Hello, everybody, and thank you very much for all attending today. Um, Today's session is just designed as a really simplistic look at what utility coring is and its main purpose. Later in the year, we'll probably be following up with a session about the reinstatement itself and how we can work with site teams to improve the performance, ensure they're getting everything right first time on site. But today's, like I say, just a really basic level overview about what utility coring is and what we can do. So firstly, I'll introduce myself. My name is James Whitworth. I work for Socotec. I'm a technical manager in our structures and pavements team. And again, I specialise specifically in the utility coring part of the process. I've been in the industry for around 25 years now. And for the last sort of 15, 20 years, I've really been based around managing these type of coring works. The presentation itself will take roughly 20 minutes, and then we've got plenty of time afterwards for any questions and answers, like Kaylee's just said. So we'll get started. So what is utility coring? So each year, approximately £7 billion is spent on the UK's infrastructure because of the need for utility providers to access their assets below the surface of our carriageways, footways, footpaths, cycle paths and verges. That may be because they need to add, check, repair or replace one of these assets. The severity of the level of the excavation can range from a simple trial hole excavation in a grass verge to a full road closure of a busy A road within a city centre. As the UK's road network began to grow rapidly from the advent of the automobile up until the 1980s, there was only a limited/basic guidance on how street work should be completed. This often led to a substandard repair works being carried out on our roads, which in turn could then become dangerous to pedestrians and motorists alike. So, the Department of Transport issued a set of guidelines and working practices that we still use today. Once all of the utility work is completed, the site needs to be fully reinstated to a permanent standard in line with the requirements of the specification for the reinstatement of opening in highways, which is used in England and Wales, or the specification for the reinstatement of opening in roads in Scotland. This is where utility coring comes in. A small, usually 100mm diameter core specimen is taken from the completed bituminous reinstatement, and the core is then used to check the requirements of the depth, material type, and laboratory air void testing to ensure that they comply with the requirements of the SROH and SROR. So for us, that process involves attending site, selecting the correct reinstatement when we get to site, drilling the core in line with the required UCAS procedures, checking the depths against the requirements of the SROH and SROR for the depth of the surface course, the binder course, the overall depth, and then testing in the laboratory for the air void testing in line with the bulk and max density requirements. Why is coring essential? Coring completed reinstatements is the most effective way to prove that works have been carried out correctly. From the perspective of a local authority, checking the works of utility providers is essential to gain confidence that the utility companies and their supply chain are working to that expected standard. For the utility providers themselves, checking a percentage of work by means of coring often provides assurances to the local authorities that the company wants to complete the works correctly and have nothing to hide. For subcontractors and reinstatement gangs, it's a good way to show that they're happy for their works to be audited and that they're confident that all of the works are being completed as planned. Such an exercise and attitude towards their work can be instrumental to accessing approved supplier status from the larger utility providers and or the local authorities themselves. Then finally, for the general public, there's less disruption to the network when work has been completed correctly first time, so revisits aren't needed. So what can go wrong? If coring checks aren't completed on a certain percentage of finished works, there could be a fair chance that the quality of the overall workmanship produced could be compromised. This could lead to revisits to complete the works correctly. On that point, if the works aren't getting done correctly each time, you're going to have to just keep going back to complete the works again and again. This could then lead to extra costs. Again, the time and the extra materials required to sort of go back to the same job twice to do the works correctly is going to be an issue. There's going to be a loss of reputation. Again, if it appears to the public that the same road set up and the same traffic management set up to complete the same work over and over again, then that's going to lead to issues, which in turn can then lead to more work pressures because you're not getting on to completing your new jobs because everything's sort of backing up because again you're just revisiting the same sites over and over again, and it can lead to dangerous site conditions where the work's not being carried out correctly. And again, if you look at that photograph on the screen there, that's where a reinstatement's really failing. It's a heavily traffic road, and because the reinstatement's not being carried out well to begin with, it's just breaking up, and that's going to certainly require a revisit for the work to be carried out correctly. What are the benefits to coring? A greater level of trust from the local authority or the main contractor about the overall quality of the work. Enhanced quality of work from subcontractors who know that they're regularly getting checked on all of their work. A getting it right first time attitude from all involved. And less costs, fines or revisits to correct substandard works. And then the main one from our perspective is being able to issue that UCAS accredited test certificate, which goes to prove that the reinstatement is fully compliant for everything that we've checked it for: the depth, the material type used, and the compaction of the air void percentage from the laboratory. So how can Socotec assist you? We've got a few headers here. The first one is the traffic management. So all of our expertly trained site technicians hold their full New Roads and Street Works Act operative qualification. This enables us to set up a basic traffic management setup at each site, which is generally a short duration work. That enables us to safely set up and drill the core without any need for further traffic management requirement from yourselves. But on busier areas such as close to roundabouts, junctions, busy A roads, busy town centres, we can also work within a pre-arranged traffic management setup, whether that be provided by ourselves and yourselves. There's the core extraction, as we talked about earlier. So once we're all safely set up on site, we'll come along, we'll check that the site is safe to core, and we will take a core sample, as you can see from the small picture under the orange tab there. You can see that we take the core through the full depth of the bituminous material, excuse me, until we're certain that we're through onto the unbound material beneath. We usually do that by just ensuring that we've drilled all the way through the core. We take a little small section of the unbound material out, as you can see in that photograph. From there, we measure the core as in line with the requirements of BSEN 12697 Part 36. Again, fully UCAS accredited for this process. We then derive the mean depth of the surface course, the binder course, and the overall depth of the core from that. And again, we can make a quick criteria check against the SROH/SROR to ensure that the depths and material type used are correct. From there, we log and safely transport and retain the core in the vehicle, and then we clean up the site and we reinstate as per again the instructions of the SROR, using a HAPAS approved repair material. From there, our core sample, if it passes the on-site criteria check, goes into our testing laboratory for air void testing. Again, all of the essential parts of the air void testing, the bulk density, the max density, and the air void percentage are UCAS accredited. And again, we then check those against the requirements of table S10.1 within the SROH and SROR. And at that stage, if the depth of the core is correct on site, if the material types used are correct on site, and the air void percentages are within the specification limits from the standard, then we'll issue a test certificate. If all of those parts are right all the way through, it will state that it's a pass. If it is a failure at any part of that process, our test certificate will clearly show where the core has failed, and then we can give you some guidance on what would need to be rectified to improve that. That's about it from me at this stage. So if anybody's got any questions, please ask as Kayla requested to begin with, and let me know if I can answer any of them for you.
Thank you, James. That was really interesting. I've noticed, Debbie Richards, you've got your hand raised. Wasn't sure if that was an accident when you joined or if you have a question or not. Just enabled your microphone for you. If you want me to lower it, I can do.
Apologies, that was a mistake when I was logging on. Do apologise.
That's okay, not to worry. Just thought I'd check just in case you did have any questions.
Sorry.
That's okay, no worries. Let's have a quick look. So, we've got a question from one of our own, John Steers. What percentage of excavations require testing? John, I'm also going to enable your microphone for you once I find you in the list, just in case you've got anything to follow up from the answer. Bear with. But James, did you want me to read that out again, or did you catch that question?
No, I caught it. Thank you very much. Yeah, it's generally all performance based. So each one of our clients will sort of approach us and let us know the percentage of works that they feel that they need to carry out themselves. It's usually performance based, so it's generally around 2 to 3% of the works if everything's okay, but that can ramp up massively to 10%, and as far as 20% if there's a real underperforming gang or utility. So we can just work with our clients to sort of increase or decrease that number as performance either increases or decreases.
Okay, thanks, James. I was just wondering if that was a percentage stipulated by the Department of Transport, or that was something that we advised upon based on the core sample that we took or performance of their reinstatement. But I think you've answered that, so I appreciate that. Just while I'm on, if you don't mind me asking another question, just approximately how long does it take to extract, to test, reinstate, and provide the details of the material that we've taken away, please?
Yeah, of course. So for a what we call like a basic site, so just like a site on a suburban road, getting to site, setting the TM up, it's only a sort of 10 to 15 minute process to extrude the core on site. So depending on how many cores we have in a specific area, we generally do around 10 to 15 cores in a day. When we get those, we can share the results of the site data with our clients more or less instantaneously if needed to. But then once all the core for that particular batch has been completed, any passes from site will go into the lab for the air void testing, and then the process is usually around sort of 10 to 15 working days until the results of the lab tests are back with us, and we can issue the final test certificate to our client. Okay, thanks, James. And I'm not sure whether you'll be able to answer this question, but just in terms of collaboration opportunities for us as a wider business, who are our key clients who utilise this service, please? We work closely with many clients across all utility sectors, but a lot of clients that we work with. We have a lot of clients specifically in the telecoms arena. So clients such as Openreach, Cersei, Comex, clients such as that. And then again, we work on water contracts across the Severn Trent water area. We work on contracts for gas as well, and we're just always looking to help out as many existing or new clients as possible.
Okay, thank you very much. Thanks for answering my questions. That's all from me. Thank you.
No worries.
Thanks, John. So we've got another question from, apologies if I don't pronounce this correctly, Sabri. What is the difference between utility and structural coring, and how should they be logged? And they've also asked, do they follow the same British standards for rocks and soils, or are they different?
Great question. Yeah, there's a slight difference. So utility coring, or reinstatement coring as it's sometimes known, is just coring that's specific to a reinstatement that's being carried out in the road or highway. And that is just based on the SROH and SROR, the requirements of those specifications. And we're just drilling a bituminous core and checking against the requirements for the compaction as per those standards. Quite different. I mean, very similar means of extruding the core to the other samples mentioned, sort of through concrete and through rock. But these various different samples. So, for instance, a concrete core is taken to BSEN 12504. Whereas all of our work for this bituminous coring is based around BSEN 12697.
No, thank you, James, for that. It's me, Sabri Omar. I've got another question if you allow me to do that one as well.
Of course.
What type of testing we're looking for here? Is it the same as we do it in the rocks and soils, or is it different from that one?
I think it'll be slightly different. So I assume with rock, you'll be looking at sort of doing either point load test or compressive strength tests.
Yes.
Similar to a concrete core, obviously we generally do a compressive strength test on a concrete core. For the bituminous core, for the utility coring, all they're actually looking at is the air void percentage. So we just carry out a bulk density and a maximum density test, which obviously we then derive the air void percentage result from.
That's great. Thank you. Last things, what is the deepest scoring you can go for utilities?
So for utility coring, it doesn't tend to be that deep comparatively to like you say, some other structural investigations that we may do. In the standard, the sort of the deepest core that's in there is a type 1 core, and as a rough guide for that, a type 1 core to sort of pass for utility coring only needs to be around 335 mil deep. So we're only looking at for a footway core. We're generally only coring roughly between sort of 60 and 100 mil deep. Most of the bituminous surfacing is only around that deep, and for a lot of the carriageways, specifically on smaller suburban roads, we're usually drilling to a depth of around 100 to 150 mil. So not sort of meters deep or anything like that.
Oh, thank you.
No worries.
Fab. And I believe we've got a raised hand from Nicholas. So I'm just going to enable your microphone, Nicholas, for you to ask a question. Okay, Nicholas Davies, your microphone
Sorry,
is...
I just realised that to click the unmute. So based on the performances of the gangs, are the coring going to be requested at any time, or is this just going to be based on like when Cat B defects start coming in from local authorities and things like that?
Again, a lot of the companies that we work directly for, so the utility providers themselves, they might want to sort of always continue a regular program of works, just to ensure that there's sort of that policing check in place.
Yeah, so just random sampling then, basically.
Yeah, just random sampling, just a percentage of their works, or if they suspect that a gang or a team's not working well in a specific area, they can sort of ramp up and further check that area. But yeah, if performance was consistently bad across the board, they'd sort of increase that percentage of overall
Yeah.
work.
All right, brilliant. Thanks for that.
No problem.
Thanks, Nicholas. And we've got one more in the chat from Mike. So Mike has asked,
Okay, mate.
how are the
Show me a picture.
extracted cores kept free from contamination and damage whilst in transit from the site to the laboratory?
Yeah, well, that's a really good question. What we do is when we take each core on site, we photograph it, we measure it, and we log it while we're there on site. We put it in its own specific container, and then we've got some crates in our vehicles that we put the samples in, so we contain them. The samples are never stacked on top of each other or sort of rolling about in the back of the vehicle or anything. We take a real care with that, just to make sure that everything's sort of segregated and transported as well as we possibly can to get it back to the laboratory safely.
Thanks for that, James. Mike, I hope that answers your question for you. Any other questions that anyone might have? Okay, we've got one from David, sorry. To establish the air void content of a core sample, please can you describe how the laboratory tests the maximum density and bulk density, please?
Yeah, of course. So at first, when we first get the sample back to the lab, the first part of that process would be carrying out the bulk density test. So what we do first of all is we leave the core out to dry until it's reached constant mass, just in a temperature controlled 20-degree room. It usually takes around 2 to 3 to 4 days for the sample to sort of dry out of its own accord to reach constant mass. And when we do, we just follow the sort of Archimedes principle of weighing that core in air and water at that stage. So what we do is we weigh it in air first, and then we seal the specimen fully. We then weigh that same sample in water. We take that back out. We strip the sealant off, and then we just weigh it again just to make sure there's been no leakage into there. And from there, we're able to derive the bulk density. The core is then actually completely broken down. The materials are separated, and then it's basically for the maximum density. It's just a principle similar to that of a particle density in soil, where we've got a known volume container. We just fill that container with deionized water, and the sample itself, and then we've got a known volume, so we can work out the maximum density of that particular sample, and then just using the bulk density against the maximum density result ascertains the air void percentage.
Thank you very much. So, Andy, you've got your hand raised, so I'm just allowing your microphone now if you want to ask a question.
Yeah, sure. Hi there, James.
Hi there, you okay?
Yeah, good, thank you. Yeah, just one question. So we're frequently asked by our partners, who we obviously get the coring done on behalf of, to potentially, on the back of an air void failure, to go to the local authority to ask if they'll agree, have a Section 12 agreement where we don't go back and reinstate or dig out and reinstate the site again. What do you perceive the risk of where we might enter an agreement where we may, go 2 or 3% above the failure rate, and then we don't then reinstate, and then what the risk sort of moving forward with that if we leave that one to run its course and see what happens? Because obviously you have tolerances in place for a reason.
No, that's it. And I mean, it's pretty black and white from our perspective because the sort of the tolerance is there in the standard. So it's really simple for us. If something's sort of 1% above the, let's say something's 1% above the
Yeah,
maximum, then unfortunately our certificate does have to show that as a fail. You may make the decision yourselves. Let's just say, for example, it's a footway that's ever so slightly failed on air void. It's an area that's gets very little footfall, very lowly trafficked. It's going to cause more disruption to go back to site to rip it up to annoy the little old lady that lives outside number 27. You may decide that to if everything looks okay on the surface, if everything looks as though it's not gonna move, you may decide to sort of take that risk yourself. But again, for us, we wouldn't be able to sort of put a note on there about that. From our perspective, it's very much a black and white sort of pass fail.
yeah. I remember us having conversations many years ago when we had that meeting. I think in Exeter, with yourself.
Yeah, a long time ago now.
It's a long time ago now, yeah. But we do see it more and more now where the local authority are actually asking us to go into an agreement on that because they don't want the disruption, but they still want us to pay for a failed core as such, you know.
Yeah.
But yeah, that's something that we have to manage moving forwards. But also just back to Mike's point around how you store the cores. Obviously, when you brought those down to Exeter, we saw firsthand how they were stored when you've got, you know, multiple cores and they're all segregated out and stuff like that to avoid them being smashed to pieces and end up like a bag of granola like some of the cores that were taken. But
no, it's essential, and again, even in these sort of cold conditions, a core can, if bituminous cores are stacked on top of each other, they can warp and change their overall like shape and being, if you like, just from being stacked. Even obviously, it's much worse in the summer, but yeah, it's just not something that we'd ever risk, and the transportation and the care of each core is something that all our techs are trained on and is essential for us as we do our day-to-day testing.
Thanks, James.
No problem.
Thanks very much, Andy. So we've got another question in the chat from Jonathan. It says, we know hand lay methods create additional difficulty in achieving air void compliance compared to machine lay. What advice or pointers would you give in terms of achieving the required level and consistency across the patch?
I mean, yeah, it's a tricky one. I know I know in the standard there is the suggestion that you can hand compact, but my personal advice would be to machine compact wherever possible. And getting the required level of compaction by hand is going to be difficult. It's a more time consuming process. Obviously, when you're working around an asset, when you're really close to that, you need to work by hand. That's totally understandable. With the coring, we always try to stay at least 100 to 150 mil away from the edge of any asset, or 100 mil away from the edge of each reinstatement. So where you're having to sort of hand compact around that, then that's sort of understandable. But yeah, on the whole, I just try to ensure that you can work with machine and you ensure that you certainly have the correct compactive effort on there, and that the gangs are carrying out the correct number of passes as well. It's vital, and to get the materials to work as they should, it is essential that those that all aspects of that is followed.
Okay. I think we've got a couple more here. So thanks for that question, Jonathan. I hope that answers that. We've got a question from John. When using cold lay tarmac, how much does weather, i.e. raining, affect the compaction for when it's cored?
I assume you mean if the gang were reinstating the full patch using cold lay. I mean, I don't think rain should affect it that much. Again, you've got to make the call on whether the conditions are right on site to reinstate. If all of the if all of the sub base is absolutely sodden because there's sort of severe weather and things like that, then you've got to make a call on whether you should even be sort of carrying out the excavation or the reinstatement on that day, or at that time. Obviously, in an ideal world, all of the spec and all of the standard are wrote that everything's a perfect condition. I know it's not always like that, but yeah, in short, I don't think the rain should necessarily affect the cold lay materials. As long as the compaction and the number of passes and everything required is done correctly, I think it should still work as should.
Okay, thanks, James. John, I hope that answers your question for you. I've got a question from Catherine. One of the most common queries that we receive back when we cascade intention to core information to our subcontractors is that the reinstatement is for a floor box or around a pole, where the deep excavation is limited to the pit and the surrounding area would just be surface course. Would this be taken into account when selecting sites or measuring depth?
Yeah, certainly would be. If I mean, a lot of coring works around a telegraph pole, and such things like that. Where we are sort of, it wouldn't allow us a safe space to take the core anyway. And I know that when we work with utility providers who we work on behalf of, we make this really clear when we're setting up the coring program ourselves. If any tracks are too narrow for us to safely core or worked around tight boxes or telegraph poles are there, then we'd sort of suggest that it wouldn't be safe to core those areas anyway, and we'd encourage our client to take such works out. On the instance where you might have only gone through a surface course and the binder course area has been left as existing, then we'd sort of make that note and discuss that in advance with our client, and we'd just proceed with caution from there and get the best possible information from the just potentially just from the surface course.
Thanks for that, James. Catherine, I hope that answered your question for you. We've also got a raised hand from one of our guests, so just bear with, and I'm going to enable that for you. So you should be able to unmute and ask a question directly to James. I think perhaps it's it could have been an accident if they've raised their hand. Okay. Well, we'll leave it there for now. Unless anyone does have any last minute questions for James. Just to let you know that the presentation will be available via email as a follow-up to this session. And then we will also be sharing the recording link with you. That should be available on the Soccertech UK YouTube channel shortly. So just an invitation for any further questions. No, I don't think there's anything coming through at the moment. So we'll leave it there. Lots of people saying thank you, James. It was really, really informative, and some brilliant questions as well. So thank you very much for taking the time to do that for us.
No, thank you, and thanks everybody for attending. It's been great to do this really basic session, and if anybody's ever got any further questions, wants to drop me an email or a call, please feel free to do so.
Yeah, the contact details for James are on the screen there, but will also be shared again with you in the follow-up email. So don't panic if a question comes to you a bit later on and you want to get in touch. Thanks very much, everyone. Much appreciated. Thank you,
Thank
Jim.
you. Thank you very much.
Thank you.